Right, this is the third video for chapter 26, covering pages 503 to 510. So we've talked a lot about light. Something that always goes with light are shadows. But have you ever really noticed what creates what type of shadow there are? So there can be sharp shadows and there can be blurry shadows. In order to get a sharp shadow, you either need to have a far away light source, like the sun, or a very small nearby light source, like a flashlight shining on your hand and you're creating little shapes on the wall. The farther also away that your hand, the closer your hand is to where you are making the shadow is also going to give you a sharper shadow. So for the most part, the sun is going to give you very sharp shadows because it is a large, far away light source. Now you can see from this little picture that these leaves right here that are close to the sidewalk are making a sharper shadow than these leaves that are far enough away from the sidewalk that we can't see them in the picture are making a blurrier shadow. So the closer you are to the wall or ground that you are creating the shadow at, it's going to give you a sharper shadow as well. So a blurry shadow is going to be made if your light source is really big and it's really close to you. So if you are looking at, say, a stage and you have the spotlight. The spotlights are always really far away because the far away spotlight cast on a person on a stage is going to create a sharp shadow. If the spotlight gets closer, the closer you are to the person, the blurrier that shadow is going to be. That tells you that that large light source is too close by. If an item is far away from the surface the shadow is being cast on, you're also going to get a blurry shadow. So the farther away you move from the wall when you're creating your hand puppets, the bigger your shadow is going to get, but the blurrier your shadow is going to get. So here would be an example of a hand, and this is a small nearby light source, which you would normally think is going to give you a sharp shadow, but because they are so far away from the wall that they're creating the shadow on, it's a very large shadow and it's very blurry. There's a couple different types of shadows besides sharp and blurry. We call them the umbra and the penumbra. So the umbra is going to be a complete shadow and the penumbra is going to be a partial shadow. Have you ever really looked this up? Most of the pictures that if you look it up are about the eclipses, because when you have a solar eclipse or a lunar eclipse, generally you're going to have an umbra, which will be a complete shadow, or a penumbra, which will only be a partial shadow. So this would be an example of that. If you had a light source on either side, so right behind your object that's creating the shadow, you're going to have the complete shadow, which is going to be the umbra. And then you'll have little shadows off to the side, which would be your penumbra. So when we are seeing light, which light is really the only thing that we can see, we're using a miraculous gift that God gave us called our eyes. The eye would be the thing that even Darwin was like, I don't understand how an eye can just happen. There's no way that all these little pieces fit together perfectly except by a creator. So that even stumped him, made him think twice about publishing his theory of evolution. Not enough to decide that there is such a thing as a God, though. So inside your eye, you've got your cornea, which is going to be that transparent cover that the first place that the light enters, and it's going to bend the light in order to focus the image to the back of the eye. So the cornea is the first place. A lot of times if people have vision problems, the cornea is usually misshapen slightly. And if you go in and you have LASIK or PRK surgery on your eyes, what they're going to redo is they're going to reshape that cornea in order for it to be the right size and dimensions to focus the light correctly on the back of your eye. The second place that the light bends is going to go through the lens. So you've got your cornea in front, and then you've got your iris here, and then you have the hole in the middle of the iris, which is where your pupil is. So the black spot in the middle of your eye is actually just a hole, and it looks black because there's no light shining from the back of your eye outward. In a picture, whenever you get red eye, that is the light bouncing off the back of the eye and shining back through, causing the red picture, or the red in the pupil. So the pupil is really just a hole. The size of the iris is controlled by a little muscle. So if you need more light, it opens up that pupil, makes the hole bigger so that more light will fit in. And if you need less light, like if you're stepping from a dark room out into that back door there by the playground, that concrete is so bright, it can cause your pupils to constrict very, very quickly. So your light's going through the cornea, it's going to bend, and then it's going to go through the lens right here, and it will bend some more. And the point is to focus it to the correct spot in the back of your eye. Now, the layer of your eye in the back that is sensitive to light is going to be the retina. You don't have retina everywhere, you just have retina at the back. And the fovea is the center of that field of view. So you're trying to focus the light onto the fovea right here. So the reason vision problems would happen is because the light may be focusing slightly off from the fovea, and that doesn't register in your brain as a clear picture. The optic nerve is going to take all of those signals that your eyes make back there, the rods and cones that are back here in your retina are sending that information to your optic nerve, which is right here. And where the optic nerve is entering from your eyeball into your brain is an empty spot called the blind spot. That's the spot where the optic nerve leaves, and so you don't have anything to recognize light or color or motion there at your optic nerve. So our brain, what it actually does is it fills in what it thinks it sees so that we don't notice the blind spots. You probably don't even know where your blind spot is when you're looking, but everybody has one. And so what it is where your blind spot happens on your left eye, your right eye fills it in. And where it happens on your right eye, your left eye fills it in, and your brain completes that whole picture, taking what your separate eyes see and making one big picture. Inside your retina, there are two types of little antennae. One sees motion and one sees color. The ones that see motion are going to be your rods. They mainly are on the outside edges of your retina. So the periphery, your peripheral vision, you can't really see color very well over there. Mainly what you see is motion in your periphery. And so low intensity light, weak lights like distant starlight are going to fire your rods more than your cones. And so your rods don't see color at all. They see motion. So when we look at the starlight, everything looks white is because that light is very weak and distant. And so we don't really see the light from the starlight with our cones. We see them with our rods, and that's why they appear white. So cones are what see color, and the cones are mainly clustered there at the back of the eye and the fovea. There are three different types of cones. There are cones that are designed to see low frequency light, cones that see the intermediate frequencies, and cones that see the high frequencies. And what that really means is that we have cones that see red, we have cones that see blue, and we have cones that see green. And those are really the only three colors we can see. Our brain tells us what the other colors are based on how much those three cones are fired. So these are going to be very dense in the fovea area where your cornea and your lens are trying to focus the light onto the fovea to fire those cones to create an image that is sent to your brain. Now, in order for this to happen, you have to have high intensity light in order to see the colors. So the lower the intensity of light, the less you can see the color. So another interesting thing that happens, because our eyes see certain things and reflects to our brains what they're actually seeing. So some of these drawings are really cool. All these are chalk drawings on a sidewalk. But our brain looks at it and says, oh, that tiger is real and that lady is riding it. This one's really cool. It's one of the ones I enjoy with the water going down the drain. But none of that is real. The guy's real. That's about it. This one's pretty fun. I would really love to go to a city where they do these sidewalk chalk drawings and check one out for real. This one's always really fun. Okay, but this one's my favorite because that car really does look like it's fallen into a sinkhole of water. There's not really a car there. And then this one's really fun too. I love optical illusions. They're really fun. How our brain and our eyes work together to tell us what's really out there, but it's not really out there. There is a quiz today. Go ahead and click on the link. Take the quiz. Have a good night. I'll see you later.